Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel, please don't forget to subscribe and press the notification bell so that you will be updated of my future videos. Now, this is about basics of statics, and I call this for beginners. So that's why I call this Static Zero. So for those who want to review important mathematical requirements so that you will be successful in your studies with statics, or for those who are already good in statics to further enhance your skills in statics, then you must review or consider this video so that you can also improve your techniques in solving, analyzing mathematical problems as well as uh, pure problems in statics. So I hope that you will enjoy watching, and your time for watching this video will be uh, enjoyable and fruitful, and I hope that you will learn a lot from this video. So let's have first the reporting of numerical values or numerical answers to problems. So all numerical answers should be reported to 4 significant figures. Examples of 4 significant figures are shown below. So 1245 is a 4 significant figure. Then it is also 124.5, 12.45, 1.245, 0.1245, 0.01245, 0.001245. These are all 4 significant figures. Another example would be 3050 or 305.0, 30.50, 3.050, 0.3050, 0.03050, and 0.003050. So those are 4 significant figures. So next is, this is important from algebra, we have axioms of equality. So of course, this is applicable for real numbers because we only consider real values in statics. So if A is equal to B, then the following statements, mathematical statements, are correct or true. So A plus minus K is equal to B plus minus K. Then we have A times K is equal to B times K. And third, A divided by K is equal to B divided by K, where K is a constant, positive or negative constant. Then fourth, if A is equal to B and B is equal to C, then we conclude that A is equal to C. So of course, that's true. Next is the commutative law for addition and multiplication. So same condition that the elements here are real numbers. If A is A, then the first statement is A plus B is equal to B plus A. That's commutative law for addition. 4 plus 5 is equal to 5 plus 4, as an example. A times B is equal to B times A. 4 times 5, 20 equals 5 times 4, 20. Then, of course, if AB is equal to 0, then either A is equal to 0 or B is equal to 0, with the possibility that both A and B are equal to 0. So, although this is not part of commutative law, but it is also a good reminder for you to consider because you might encounter this situation, or there is a big possibility that you will encounter that situation. The next is solving an equation with only one variable. So let's have two examples. Solve for the variable x from the equations below. So that's the first, that's the second example. So for the first example, we have to multiply everything, both sides, by 4, which is the LCD of the denominator. So the first equation becomes 5 times quantity x plus 3 is equal to, because this is multiplied by 4, so 6x plus 8. So that's the result. Then then distribute. So we have 5x plus 15 equals 6x plus 8. Then subtract 5x from both sides of the equation. So 5x plus 15 minus 5x equals 6x plus 8 minus 5x. So simplify, we have 15 equals x plus 8. So therefore, if we subtract 8 from both sides, we get x equals 7. So 7 equals x, or x equals 7. So that's the solution to the first example. For the second example, let's do checking, and you always do this to make sure that your answer will be correct. So we have to substitute 7 in equation 1. So 5 times 7 plus 3 over 4 should be equal to 3 times 7 over 2 plus 2. So this is 1.25 times 10. This is 10.5 plus 2 at the right side. So 1.25 times 10 is 12.5. 10.5 plus 2 is 12.5. So 12.5 equals 12.5. Then for the second problem, so we have to add 3x plus 4 from both sides. Then the left side becomes 65. The right side, the LCD, is 12. So the first term becomes 12 divided by 3. So 4x plus 12 divided by 4, 3x plus 3. 3x times 3 rather is 9x. So 4x plus 9x over 12, the LCD. Then multiply everything by 12. 65 times 12 equals 13x. Then divide everything by 13. So 65 over 13 is 5 times 12. So x is 60. So x is 60. So that's the solution to the second example. And we check our work by substituting x is 60. So 65 minus 3 times 60 over 4 is equal to 60 over 3. 65 minus this is 45 equals 20. So 65 minus 45 is 20. So 20 equals 20. So that's the solution. So next is solving simultaneous linear equations in two unknowns. So let's have an example. Solve the system of equations below. So first equation, 3x minus 5y equals 7.5. Call that equation 1, and 2x plus 3y equals 0.25, equation 2. So by substitution method, so first, the first equation, we add 5y to both sides so that the first equation becomes 3x equals 5y plus 7.5. Then dividing everything by 3 so that we can express x in terms of y. So x is 5/3 of y plus 2.5. So of course you have your calculator there. 7.5 over 3 is 2.5. We substitute this value of x into equation 2. So 2 times quantity 5y over 3 plus 2.5 plus 3y equals 0.25. Then we distribute 2. So that becomes 10/3 y plus 2 times 2.5 is 5. So 10/3 y plus 5 plus 3y equals 0.25. Then we combine 10/3 y and 3. So that's 19y over 3. Then 0.25 minus 5 is negative 4.75. So 19y over 3 equals negative 4.75. Then to solve for y, we multiply everything by 3 over 19. So the left side becomes y, and the right side is 3 times negative 4.75 over 19, and that would be negative 0.75. Substitute this value of y into equation 1. So x, or into this equation, 5/3 of negative 0.75 plus 2.5. So that would be x equals 1.25. Then we will not check the answers because we have another solution by elimination method. So these are our answers by this method. Then by second method, solution 2 by elimination method. So the first equation is 3x minus 5y equals 7.5. And one way is we want to eliminate x, so we multiply equation 2 by 1.5 to make this 2x here equal to 3. So that would be 3x, multiply everything by 1.5. So 3x plus 4.5y equals 0.375. So that's equation 2. After we multiplied everything by 1.5, then we can now subtract equation 2 from equation 1 so that we can eliminate 3x. So negative 5y minus 4.5y is negative 9.5y, and 7.5 minus 0.375 is 7.125. So negative 9.5y equals 7.125. Divide both sides by negative 9.5, so we get y equals negative 0.75. Then substitute into equation 1, 3x minus 5 times negative 0.75 equals 7.5. So because you have your calculator there, you can check that it is 3x plus 3.75 equals 7.5, or 3x equals 7.5 minus 3.75 is 3.75. Then 3.75 over 3 is 1.25. So divide everything by 3, so x is 1.25. So the answers are the same. Therefore, x is 1.25 and y is negative 0.75. So that's it. Then another topic would be solving simultaneous linear equations in 3 unknowns. So we have the same approach, eliminate by substitution and by elimination. So let's have this example. Solve the system of equations. These examples are equations in the structural analysis. You might encounter these equations by least work, and that's the future subject in civil engineering. Of course, after mechanics of materials or the strength of materials. So this is the first equation, the second equation, and the third equation is 264ax plus 332.5ay plus 35ma equals 16,470. So the first solution is by substitution. So we simplify the first equation. We express ax in terms of ay and ma. Same is true with the third equation. It's easier to express ax in terms of ay and ma. Then we substitute this into equation 2 so that we'll have ay and ma as the unknowns. So let's write again the 3 simultaneous equations. So another way is to express ax from equation 1 into ay and ma, then substitute it into equations 2 and equations 3, leaving the unknowns in terms of ay and ma. Then from equation 2.1, from the result here, after we express ax in terms of ay and ma, we then solve ay in terms of ma, then substitute it into equation 3.1 so that we can solve for ma. So let's do it. Although you may opt to choose any of the variables to be eliminated first and to be solved first. So the principle is the same. So first, from equation 1, we divide everything by the coefficient of AX, which is 2544, to get AX equals 106380 over 2544 is 8865 over 212. Then if we move this term to the right, it becomes negative. So negative 2508 AY over 2544 is negative 209 over 212 AY. Move this to the right, so negative 264 over 2544 is negative 11 over 106 MA. So you have your calculator there, so you can check if the terms here are the same. Then we substitute this into equations 2 and 3, and we call the resulting equations as 2.1 and 3.1 respectively. So in equation 2, 2508 of AX 8865 over 212 minus 209 AY over 212 minus 11 MA over 106 plus 13640 over TAY plus 332.5 MA equals 263137.5. So let's simplify this. So we have, let's simplify first AY, negative for 2508 times negative 209 AY over 212 plus 13640 over 3. Then that would be AY. Then for MA, negative 2508 times negative 11 over 106 MA plus 332.5. Then we'll have to combine the result. Then for the constant, 263137.5 minus 2508 times 8865 over 212. Because if we move this to the right side of the equation, it becomes negative. So again, 2508 times negative 209 AY over 212 plus 13640 over TAY, that would be 2075.157 AY. Then 2508 times negative 11 over 106 MA plus 332.5 MA is 7657 over 106 MA. Then 263,137.5 minus 2508 times 8865 over 212, that would be 158,262.877. Let's call that equation 2.1. Then this value, same value of AX into equation 3, 264 times 8865 over 212 minus 209 AY over 212 minus 11 MA over 106 plus 332.5 AY plus 35 MA equals 16,470. So again, we combine values for AY. We have 264 times negative 209 AY over 212 plus 332.5 AY. That would be 7657 over 106 AY. Then 264 times negative 11 over 106 MA plus 35 MA. That would be 403 over 53 MA. Check it with your calculator. Then for the constant, 16,470 minus 264 times 8865 over 212, that would be 287,820 over 53. Then from equation 2.1, we divide everything by 2075.157 to express AY in terms of MA. Then that would be AY equals 158,262.877 divided by 2075.157, that would be 76.2655. Then this is moved to the right, so this becomes negative. Negative 7657 over 106 divided by 2075.157 of AY, that would be negative 0.0, that would be negative 7657 over 106 MA divided by 2075.157, that would be negative 0.03481 MA. Then we substitute this into equation 3.1. So 7657 over 106 times quantity 76.2655 minus 0.03481 MA plus 403 over 53 MA equals 287820 over 53. So let's combine the value of MA, 7657 over 106 times negative 0.03481 MA plus 403 over 53 MA. That would be 5.08924 MA. Then for the constant, 287,820 over 53, then minus 7,657 times 76.2655 over 106. That gives us negative 78.537. Solving for MA, negative 78.537 divided by 5.08924 So MA is negative 15.42 kilonewton meter because that's the unit of MA. Then AY, substitute into this equation. AY is 76.2655 minus 0.034181 times negative 15.42. So AY is equal to 76.803 kilonewtons. Then AX from this equation here. So AX is 8865 over 212 minus 209 times 76.803 over 212 minus 11 times negative 15.42 over 106. So AX is equal to negative 32.299 kilonewtons. So let's check the answers. So substitute into equation 1, 2544 times negative 32.299 plus 2508 times 76.803 plus 264 of negative 15.42. So the left side is 106,379.22, which is approximately equal to 106,380. Of course, we cannot expect that they are exactly equal. They are just approximately equal because we rounded off values of MA, AX, and AY. Then in equation 2, 2508 times negative 32.299 plus 13640 over 3 times 76.803 plus 332.5 times negative 15.42. Then let's check if it is equal to or approximately equal to 263,137.5. So using your calculator, evaluate the left side of the equation. The left side of the equation is 263,137.411, which is approximately equal to 263,137.5. Of course, that difference is very, very small. Then finally, in equation 3, 264 times negative 32.299, then plus 332.5 times 76.803 plus 35 times negative 15.42. So the left side using your calculator is 16,469.942, which is approximately equal to 16,470. So we conclude that all these answers are correct. So AX is negative 32.299, AY is 76.803 kilonewtons, and MA is negative 15.42 kilonewton meter. So that's it for our first method of solution, which is by substitution. Next is by elimination. So let's have second solution by elimination method. So we plan to eliminate MA first. So to do that, let's multiply equation 1. We plan to eliminate MA. So we multiply equation 1 by 332.5 divided by 264. So multiply everything, equation 1 by 332.5 divided by 264. So this becomes 2544 times 332.5 over 264. So that's 35,245 over 11 AX. Then 2508 times 332.5 divided by 264, 3,158.75 AY. Then plus 332.5 MA. Then 106,380 times 332.5 divided by 264 is 133,982.386. So let's call that equation 1.1. Then we subtract equation 2. So let's simplify. This is equation 3.1, by the way. After we multiply equation 3 here by 332.5 over 35. So the coefficient of MA in equation 3. So the first term becomes 264 times 332.5 over 35, 2508 AX. The second term is 332.5 times 332.5 over 35, 3,158.75 AY. And the third term is 332.5 MA. So 16,470 times 332.5 over 35 is 156,465. So we can now eliminate MA from these equations here. So by subtracting equation 3.1 from equation 1.1. So 35245 over 11 minus 2508 is 7657 over 11 AX. Then we can eliminate, by the way, AY and MA simultaneously. So luckily we can eliminate these two terms. So from here, 133,982.386 minus 156,465 is negative 22,482.614. So to solve for AX, negative 22,482.614 times 11 divided by 7657. So AX is negative 32.298, which is very close to our answer before, which is negative 32.299 kilonewtons. So that's okay. Then we substitute the value of AX into equation 1. To 2544 times negative 32.298 plus 2508 AY plus 264 MA equals 106380. Then we have a new equation for equation 1. 2508 AY plus 264 MA equals 188.546. 188,546.112. Call that equation 1A. Then equation 2, 2508 times negative 32.298 plus 13,640 over 3AY plus 332.5 MA equals 263,137.5. This is equation 2. Then we substitute the value of AX. So equation 2 becomes 13,640 over 3AY plus 332.5 MA equals 344,140.884. So call this equation 2A. Then we multiply equation 1A by 332.5 divided by 264 so that we can eliminate MA. So 2508 times 332.5 over 264 becomes 3158.75 AY plus 332.5 MA equals 188,546.112 times 332.5 over 264. So that will be 237,468.115. So we can now eliminate MA from these equations 2A and equation 1.AA by subtracting equation 1.AA from equation 2A. So we can solve AY. So 13,643 over 3AY minus 3158.75 AY is 16667 over 12 AY. Then 344,140.884 minus 237,468.115 is 106,672.769. So AY therefore is 12 times 106,672.769 over 16,667. So AY can now be solved 76.803 kilonewtons. Then substitute into equation 1A. So 2508 times 76.803 plus 264 MA equals 188,546.112. So we can solve MA 188,546.112 minus 2508 times 76.803. Then the result divided by 264. So that is MA. So MA is negative 15.49 kilonewton meter. So there's a very small difference to our previous answers, and that is acceptable because the method is different and we have new rounded off values or new decimal values here, as long as the answers are very close. So that's acceptable. So AX negative 32.298 for this method. AY is 76.803, which is I think the same. MA is negative 15.439 kilonewton meter. So the answer before was negative 15.42, and if rounded off or comparing, that's very, very close. So that's it for this method by elimination. There are other methods like using matrix, using matrix inversion, and other methods, Cramer's rule, whatsoever, but these two methods are methods that can be remembered because these are basic methods, substitution and elimination method. If you want to solve this by those other methods, advanced methods, then you can do so as long as you will arrive at the same answers.